In this lesson, we're going to be looking at Newton's second law. Newton's second law pertains to unbalanced forces. So with Newton's first law, all your forces canceled out, which means you stay at a constant velocity or at rest. With an unbalanced force, you accelerate. You speed up or slow down. And that's because the sum of all the forces does not equal zero. Your reference table has this equation right here. Your net force equals mass times acceleration. So when you add all your forces together, you get the mass times the acceleration. So the steps for solving Newton's second law problems, so problems where your object is accelerating, are the same kind of steps that you did before. You're going to draw a free body diagram. Always draw a free body diagram. Break it into components. Remember, we got to keep x and y separate. Set up your problem. Okay? Some of your forces in the x direction, some of your forces in the y direction. The big difference is, rather than equal 0, because it is accelerating, it equals ma. And make sure you keep directions in mind, adding and subtracting forces. Let's look at an example. A man who weighs 100 newtons is standing on a scale in an elevator. What will the scale read his mass to be in these different situations? Now, scales read normal forces, okay? How much it's pushing up. Let's draw a free body diagram because that's our first step. Well, gravity is always acting on it. So you have his weight. And you have the normal force. Now, he's not moving horizontally at all, so there's no horizontal forces. This is just one dimension. Nice and easy. Now, step 1, that. Step 2, components. No components. Step 3, sum of your forces. So sum of your forces in the y direction equals mass times acceleration. So, positive y, we have normal. Minus anything in the negative y, which is weight. Don't do that. Okay, so normal force minus your weight equals your mass times your acceleration. Now they tell you that he weighs 100 newtons. Now because it's newtons and because it says weigh, you know it's the force and not the mass. So N minus 1,000 equals your mass. Now, what's our mass? Well, Fg, which is the same thing as weight, equals m times g. So 1,000 equals mass times acceleration due to gravity, which is 10. So your mass equals 100. So that equals 100 times your acceleration. So your normal force will equal 100 times your acceleration plus 1,000. Okay? Now we just look at each of our situations. For the first situation, we're moving at a constant velocity, which means our acceleration is equal to 0. So n equals 0 plus 1,000. So n equals 1,000. For our next situation, you are accelerating up at 5 meters per second. So a equals positive 5 meters per second. So n equals 100 times 5 plus 1,000. So n equals 1,500 newtons. Now if you were going to put that into kilograms, you would just do the same thing that you did up here with this and divide it by 10. So it would be 150 kilograms, depending on what you wanted. In the last situation, we are accelerating down at 5 meters per second. So n equals 100 times negative 5 plus 1,000. So that's negative 500 plus 1,000. So n equals negative 500 newtons, or 50 kilograms. So if you want to weigh less, stand on an elevator, or stand on a scale in an elevator, and have it accelerate down. Not up, because up you'd weigh more, and that would be sad. Alright, now, this is a second example problem. This is a two-dimensional force. A man is pushing a 10-kilogram box across the floor with a force of 20 newtons at an angle of 30 degrees from the floor. If the box starting from rest travels across the 15-meter floor in 5 seconds, what's the coefficient of friction? Alright, well, let's start by adding to our free body diagram. We have 20 newtons of force, right, and that will have an x and y component. We always have gravity. Normal force. Right, we are applying a force this way, so then our friction would equal that way. Okay? So that would be our force of friction. Now we sum our forces in the x direction and sum our forces in the y direction. Alright, so in the x direction we have Fa, force applied, times cosine theta, the x component, minus force of friction, that's in the opposite direction, equals your mass times your acceleration. Now in the y direction we have normal in the positive direction, and then we have weight and the force applied in the negative direction. Okay, equals mass times acceleration. Now, the box is not accelerating in the y direction, right? It's sitting on the surface, sliding across the surface. It's not speeding up or slowing down, going up and down. So, that's going to equal 0. Alright, so n minus w minus Fa cosine theta equals 0. Okay? And in our x direction, Fa cosine theta, we have this one here. Alright, so let's see. Normal force. We do not know our normal force, minus our weight, which is 10 kilograms times 10 meters per second squared, minus your force applied, which is 20 newtons, times cosine of 30. Okay? Equals 0. So normal equals 117.3 newtons. Okay, that's our normal force. Now let's look in our x direction. Let's go with black. So, Fa cosine theta minus force of friction equals mass times acceleration. Fill in what we know. Well, I'm a smart cookie, and you have to not do what I just did. Let's go back up here. You see how for the y direction I have Fa cosine theta? I just realized that should be Fa sine theta. So that's sine theta, which will change our answer to 110 newtons. Just so we can get that correct. Sorry about that. Alright, so 20 cosine of 30 minus force of friction, which is mu times n, equals mass, which is 10, times acceleration, which we do not know. But we do know n, because we already found n. So minus mu times 110. So we currently have two unknowns. However, if we look at it, the box starts from rest, travels across a 15-meter floor in 5 seconds. That sounds a lot like the previous unit mechanics problem. Okay, so 6 variables, x naught, x, v naught, v, a, t. We're solving for a because that's what we need. We start here, we start at 0, we start from rest. We travel 15 meters in 5 seconds. We use the equation without v. Alright, we plug in our variables and we get an acceleration of 1.2. Alright. So, 20 cosine of 30 equals 17.32 minus mu times 110 equals 10 times 1.2. We find mu equals 0.048. And that is our coefficient of friction. Bam! Good luck on your homework.